Good morning to everyone. We are in the topic Ethernet, isn't it? So in this Ethernet comes under MAC protocol, right? So in MAC protocol, these are the types of MAC protocol. So we are using Ethernet in wired LAN, in wireless LAN 802.11, wireless PAN 802.15. So these are the protocol available in MAC. So in this we already started Ethernet. We have completed what is Ethernet, where it is used and how it is working, and what kind of technology is used in the Ethernet. It is CSMA CD. This also we have already covered. Carrier sense multiple access collision detection and carrier sense multiple access collision avoidance, which is used in wireless LAN. Now we move on to Ethernet physical property. So this is the structure of Ethernet. So this is it is any kind of host. It may be a computer or it may be any devices which is connected. And this is the adapter. And this is transceiver. This is Ethernet cable. So through this cable only the particular system is connected. This particular system is connected with adapter and transceiver, right? So this Ethernet, we already know that this Ethernet segmentation is implemented on coaxial cable. This coaxial cable is some limitation. So that limitation, it can be up to it support 50 meter, right? The modern Ethernet, it is using Cat5 or optical fiber. So it is supported up to 500 meter. So this is the final extension. So initially it is using coaxial cable is used for cabling, and after that optical fiber is used. This optical fiber limitation is 500 meter. This cable is similar to our TV cable, okay, television cable. So only difference is it supports 50 ohms instead of the cable TV, it supports 75 ohms. So this is the difference. So this is some introduction about the physical property. What is transceiver? So we know that transceiver is receiving the incoming signal. Okay, so that is transceiver. It also sensing the cable. So whether the cable is idle or the cable is used by some other system, some other host. So it also detects when the line is idle and it drives signal when host is transmitting. So simply we can say when it is idle, when it is busy. The transceiver is connected to an Ethernet adapter which is plugged into the host. The protocol is implemented on the adapter. So this is host. We can say this is one computer and this is adapter. We know that the adapter is used to or used by the MAC as a protocol. Okay, so the particular protocol is implemented on the adapter. The transceiver is used to detect the cable is transmitting or cable is in idle state, and also it receives the incoming signals. So these are the major responsibility of transceiver, and this is Ethernet cable. So Ethernet cable, initially it is used coaxial cable and later it can be moved on to optical fiber cable. So this is general physical property of Ethernet. And also, so the cabling can be segmented, isn't it? So there is no possibility or not able to connect all the 60 system or all the 100 system can be connected in a single cable. So there is a segmentation is there. So for that connecting of one cable to another cable, so here the repeater is used. Okay, the multiple Ethernet segment can be joined using repeaters. So it also, repeater, the responsibility or objective of repeater is just forwarding the digital signals, right? So the one restriction in this usage of repeater, so should not use more than 4 repeater in a pair of host. So this is the limitation, and an Ethernet has total reach of only 2500 meter. This is the limitation of an Ethernet. So this is how the host is connected through Ethernet along with adapter and along with repeater, right? So this is this empty box. This empty box is repeater. Okay. So here the one single cable. So it has number of segments, and each segment it is connected with the repeaters. So this is the representation of repeater in the Ethernet. So we can also there is also how to say that there is a possibility to use hubs also. Hub also, it is a intermediate device. So it is also possible to create multi-way repeater. So that multi-way repeater here we can call it as hubs. Okay. So through this hub the number of system can be connected. So each and every hubs can be connected through a cable. So this is Ethernet hub. Okay, so we have seen this cable, Ethernet cable is initially it is in optical fiber, coaxial fiber. Later it is what is it that coaxial cable is used, and now it is using, what is that? It is called it as thinner cable. Okay, so this thinner cable, the representation can be 10 base 2. Okay, so it is originally, the original version it is 10 base 5. So here the 10 means network operates at 10 Mbps speed. Okay, so here the 10 base 2, the meaning of 10 here is 10 Mbps speed. This base means the cable is used in the baseband system, right? The base represents the baseband system. Here the 2 represents the segment can be no longer than 200 meter, right? 10 base 3, 10 is speed of, that is 10 Mbps speed. The base is baseband signal, and 2 is up to not more than 200 meter. This is how the new technology is used in the Ethernet. And also the number of many number of versions available in this new cabling technology. So 10 base T stands for twisted pair, and this twisted pair length of cable length is limited up to 100 meter, and 100 base T also available, 1000 base T also available. Here the 100 means 100 Mbps, up to 100 Mbps speed can be supported. If it is 1000 Mbps, that is 1000 Mbps is speed limit. So this is these are the versions used in Ethernet as a new technology, the new cable. So till now we have seen the physical properties of Ethernet. So this is physical property of Ethernet. So it consists of adapter, transceiver and cabling. So this is this particular structure we can call it as Ethernet transceiver and adapter. So another also we can use Ethernet repeater and Ethernet hub. So this is some various devices, connecting devices is used in the Ethernet. Also the cabling also can be very, so twisted pair, coaxial cable, and recent technology is using this thinner cable. We can call it as thinner cable. That thinner cable can have this kind of representation 10 base 2. So 10 is represents speed and base is baseband signal, and 2 represents up to how much longer it is supported. So like there is number of versions available, 10 base T and 100 base T, 1000 base T, right? So that's all about basic physical property of Ethernet. Next we move on to access protocol for Ethernet. So the access protocol, here mainly we can go with algorithm. So that algorithm we can call it as Ethernet Media Access Control. We already know that it is implemented on hardware. It is implemented in hardware on the network adapter. So these are the things we have seen in a physical property. So how the Ethernet is working, what is the frame format, how the frames are sending by with the Ethernet. So this is the frame format for Ethernet, right? So this is, the first part is preamble, and next division is destination address and the source address and the type. This is the body of the message, and finally CRC, cyclic redundancy check. It is used, you may aware of this. This is for finding or detecting the errors. Okay. So this for preamble, it is allocated 64 bytes and destination address 48, source address 48, and the type is 16, and it depends on the content it is allocated, and 32 is for CRC. 64 bits for preamble, 48 is commonly 48 bits are used in destination and source address. So what is that preamble? So preamble is, it allows the receiver to synchronize with the signal. So what is that synchronization of signal? It is just alternating zeros and ones. This is the work of preamble. And we know that who is sending and who is the receiver. So that address can be represented, and that allocated bit is 48, and packet type 16 bit. So here it acts as a demultiplexer. It is used to identify the higher level protocol packet type. Okay. So this packet type is used to identify the higher level protocol. And the data, finally the body of the content or the data can be transmitted. This size of the content is up to 1500 bytes. Up to 1500 bytes of data can be transmitted in a single byte, a single message, right? So this is the data part. And the CRC, we know that the CRC, it is a cyclic redundancy check. The limitation is up to 32 bit, right? So here this is the format. You should not supposed to change the order or change the bits allocated for each and every part, right? Once again I am repeating. So here this is the Ethernet frame format. So it consists of preamble. It is allocated for 64 bit, destination address and source address for 48 bits using, and for 16 bits are used for typing, and the remaining up to 1500 bytes the data can be transmitted, and finally 32 bits allocated for CRC. So this is how the Ethernet frame is represented. Next we move on to Ethernet address, that is MAC address, right? So the MAC address we'll see in the next video. So till now we have seen Ethernet physical property and the frame format of Ethernet, right? Thank you.